This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
I think I would say I see the biggest challenge confronting the future of the industry is that of sustainability. And so the question to Parker, to the hydraulic systems division here, how do we help the airframer, the company, right, that is designing and manufacturing the airplane, as well as how do we help the airlines, the companies that are buying and operating the aircraft, to minimize their impact on the environment?
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure that you keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is, in fact, one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. That really does help promote the show and tells more and more of our friends in the industry about how they can join in on these important conversations. On today's show, our guest is Tim Althoff. Tim is the chief engineer for Parker Hannifin Aerospace in their hydraulic systems division. And today we invited Tim into our forum to learn more about some of the innovative applications of hydraulics in the aerospace market. So Tim, welcome to Fluid Power Forum.
Well, thank you for inviting me, Eric. I'm looking forward to our discussion today.
I am too. This is an important market for our industry, and you're one of the best people to talk to about it. We're excited to have you on the show. Tell us a little bit more about yourself. Give our listeners kind of your backstory. How'd you find your way into your current position at Parker?
It can be a rather long story, but I'll try to give you the Reader's Digest version.
Let's start there, yes.
Okay. I grew up in the Chicagoland area, and after receiving my bachelor's in mechanical engineering from Purdue University, I found myself working for the Garrett Turbine Engine Company, a division of Allied Signal in Phoenix, Arizona.
Mm-hmm.
After 6 years there and the birth of our son, we were looking to get back to the Midwest, closer to family. And that led us to Ames, Iowa, where I was working as a project engineer with Sauer Sundstrand,
Mm-hmm.
now known as Sauer Danfoss. And that's really where I learned hydraulic pumps and systems. The application there was not aerospace. It was the mobile market, anything from
Right.
lawn and garden tractors to skid steer loaders and large equipment such as excavators and combines.
Right.
And after I was there for 4 years, it was a call from a headhunter that led me to Parker Hannifin's hydraulic system division here in Kalamazoo, Michigan, where I've now been for a little over 20 years.
Right.
During my tenure here at Hydraulic Systems Division, I've had many opportunities. I began as a project engineer in the pump design team, but after completing my MBA at Michigan State University, I moved more into a team leader role. And I've had opportunity to lead several teams in different areas of our business, including sustaining engineering, supplier quality, the engineering design, and also factory operations.
Yeah.
I've been in my current role as chief engineer for a few years now, and that role is an independent contributor role, reporting to our director of engineering. So that kind of leads me to where I am today, Eric.
And how long have you been, in the aerospace part of Parker then?
So the entire time I've been at Parker, it has been in the aerospace group here in Kalamazoo. So roughly 24 years.
Okay. When I think Parker Aerospace, I'm always thinking out on the West Coast, but I know they have a plant out there, but I guess they have people
Yes.
all over the country, I'm guessing.
That's exactly right. Out west is Control Systems Division, Flight Controls, but it's here in Kalamazoo where the Hydraulic System Division is headquartered.
It's an interesting backstory that you just described, there, Tim. A lot of people we talk to on the podcast kind of stumble their way into fluid power. It sounds like that formative experience you had at, what'd you call it? Sauer Sunstrand? Boy, that's a name from the past, isn't it?
Yeah.
Was that really your first introduction to hydraulics at that point?
It was. Literally, I stumbled there right. The first job I had in Arizona with Allied Signal, that was in aerospace, but in turbine engines.
Yeah.
And that was my first exposure at Sauer Sunstrand.
So when you came out of Purdue, there wasn't much fluid power in their curriculum, it sounds like.
Well, I think they probably had it in their curriculum, but it wasn't an area of emphasis for myself.
Yeah. Well, yeah, I'm always, if those who have heard previous episodes know that I always ask about kind of those formative experiences with fluid power. It's interesting to learn where people pick it up and how they come first exposed to it. So that's a great story, and 20 years of experience in aerospace is going to be huge for our discussion going forward here. I'm sure Parker Hannifin is a word or a company name that lots of people have heard of, but tell us a little bit more about the company. Who are they? What do? They do that more than just hydraulics and aerospace, I'm going to guess.
Sure. Yeah, they sure do. A very diversified company. I would say at Parker Hannifin, we would call ourselves the premier company and manufacturer of motion and control systems and technologies. Parker is definitely a worldwide company, approximately, I'm going to say 14 plus billion in sales and probably around 60,000 employees. I would describe Parker as a centrally led company. We're headquartered in Cleveland, Ohio. Mm-hmm. Really at an operating level, I would say we're a very decentralized company with over 300 manufacturing facilities, of which our Kalamazoo facility is one example. Here in Kalamazoo, we have about 500 employees, I would say, roughly an even split between office jobs and manufacturing jobs. Mm-hmm. Parker Corporation is subdivided then into what we call groups, technology groups. There's probably 6 to 8 of those. Examples would be there's a filtration group, there's an engineered materials group, there's a motion systems group, and then there's the aerospace group, of which my division is a part.
Yeah.
So each of these technology groups is then further subdivided into what we would say specific divisions that can have a specific focus for a given market or a more defined group of products.
Right.
So if I would take the aerospace group, for example, Eric, I think we in the aerospace group, we have 9 discrete divisions, and some of which include the flight control actuation division. When you mentioned the West Coast, that's where they're located.
Right.
There's another division that's focused on fuel systems and inerting. There's a fluid conveyance division, customer service group, or customer service division. And then there's also the hydraulics division, of which I am a part.
Right.
So I guess I would say we're a single corporation, one Parker, if you will, with shared visions, goals, and strategies, but made up of several hundred divisions that allow us to move maybe more quickly and agilely to meet any customer or market need for motion and control.
It's an interesting, again, that's a great overview there, Tim. And one piece of information that I know about Parker and its history is that motion systems group that you mentioned is fairly recent. There used to be a hydraulics division and an automation division and a pneumatics division, if I remember correctly. And they all got kind of coupled together into something they now call motion systems, which is
That's great.
all kinds of motion technologies, hydraulics, pneumatics, electromechanical, et cetera, for all kinds of markets, mobile and industrial, as I understand it.
Mhm.
And aerospace, is one major market for hydraulic technologies and other technologies, of course, which still kind of stands alone, in the Parker hierarchy, if you will, or organization at least might be the right way to say it. So I think I'm assuming that speaks to the uniqueness and the needs of aerospace as a market. Do I have that right?
Yeah, I think that's really right.
Yep.
While the hydraulics that are in the motion control group, right, is more industrial based, a lot of very similar products, but the requirements of aerospace are different enough that it drives a demand for a unique design and product.
Yeah. So let's start, if we can, with maybe a quick overview of the aerospace market itself. Maybe it's
Sure.
obvious, but maybe it isn't to some of our listeners. When we talk about the aerospace market, what are we talking about? We're talking about aircraft, and what kind of aircraft? What are the major machines, if you will, that fit into that market?
I would say it includes both military and commercial aircraft.
Mm-hmm.
Within the military segment, it would include fighter aircraft, large military transports and bombers, as well as aircraft like helicopters, and in more recent history, unmanned aerial vehicles.
Mm-hmm.
Then there's the commercial segment, and really that's what I'll limit most of our discussion to today, Eric.
Sure.
But that includes, large large transport aircraft, such as we find from Boeing and Airbus primarily,
Mm-hmm.
but definitely with China beginning to enter that market rather quickly. It also includes regional jets, which come from companies such as Embraer, and then also business jets from companies such as Gulfstream and Bombardier.
Right.
And it also includes helicopters and some smaller general aviation aircraft. So it's a large market, a diverse market, but we really serve all of those.
So it sounds like, a trip to your local regional airport, is going to show you all of the many of the vehicles that you just described.
Yeah, exactly.
So, and as we said earlier, I mean, this market seems to be driving some, unique solutions or unique applications. Where does that come from? Are there key design or performance challenges that are unique to that class of aircraft?
Yeah, most definitely there are. When I first came and interviewed with Parker Aerospace, and I was coming from Sauer Sundstrand and mobile equipment,
Mm-hmm.
I thought to myself about aircraft, and one of the questions I asked one of the engineering managers is, how do you design pumps that never fail? Right? I was like, you can't have one of these break on an airplane.
Right.
And his response, he kind of laughed. He says, we have redundant systems, right? We have backups. So, the number one challenge, certainly, and probably clear to everyone, as a flying machine subject to the laws of gravity, safety is number one. I think in recent years, all of us have seen the significant media coverage that's generated by an airplane crash or
Mm-hmm.
by a near miss. And it demonstrates just how important safety is to everyone. So that drives a lot of quality and other types of requirements that are unique to our products. But close behind safety, also driven by the laws of gravity, if you will, is weight. Right? For an aircraft, I would say that every pound or kilogram of mass that goes into building that airplane has to earn its way on the aircraft.
Mm-hmm.
And because for every one of those pounds that goes into the aircraft structure or the equipment, that's weight that has to be paid for, both by fuel burn to lift it and carry it, and also by any reduced weight that can then go towards carrying passengers or cargo. So safety and weight, I think, are unique elements of the aerospace market that often are not in the more industrial markets, if you will. I would just also include, right, close behind those is dispatch reliability. That's probably not different from someone who operates a tractor, right? They want their airplane to be flying all the time. And we all know what it's like to have a trip delayed due to an equipment issue and the frustration involved in that. And for the airline, that can be a significant cost, both in terms of lost revenue, but also in terms of the costs associated with having to rebook a customer, provide meal or hotel vouchers, et cetera, and loss of customer loyalty.
Yeah. It sounds like those are applications that demand a high degree of reliability from all of its systems, right? They can't fail, as you described.
That's exactly right.
But they have to perform at the lowest possible weight, it sounds like.
Yes. I mean, it's always a trade,
right?
I mean, weight at the cost of reliability may or may not be a fair trade. And I think I'll talk about that a little bit more in our discussion. Weight is something that can't be ignored on a machine that has to fly.
Well, as you said, Tim, let's get into some of the reasons why hydraulics is a good solution to some of those performance challenges that you just described. But before we do that, we've reached the stage in our show where we just have to take a short break to provide our listeners with an update on some other opportunities in the fluid power industry. I'd like to tell you about a series of quarterly conferences NFPA conducts with the Fluid Power Industrial Consortium. That consortium is an industry networking group established by the Milwaukee School of Engineering, and with them, NFPA offers this quarterly series of conferences on the latest fluid power technology advancements with immediate implementation. These conferences are open to everyone. The consortium helps bring a broad group of stakeholders to these events: fluid power suppliers, component manufacturers, distributors, and OEMs all come together to hear and discuss presentations on the market-ready technologies that are affecting their businesses. Fluid power technology advancements is just one example of the topics that get much deeper coverage at these conferences. If you like what you hear on Fluid Power Forum, you're going to love what happens at these events. For a full schedule of quarterly conferences and topics, head to nfpa.com and click on the Events tab. They are truly a way to bring this wide and diverse industry together for education and networking. Okay, we're back from our break, and I'm talking with Tim Althoff of Parker Hannifin Aerospace Division, and we had just got through describing some of the performance challenges in the aerospace market. And I think we were about to transition, Tim, to a discussion about hydraulics in the market and why hydraulics is a nice or a good solution for some of those challenges. Can you describe for us, maybe generally speaking, where we're likely to find hydraulics and what is it doing on some of these aircraft?
So if we first talk about where we find the hydraulics on the aircraft, I'll say this: it's really surprisingly throughout the aircraft. Hydraulics is responsible for controlling the movement of multiple parts on the airplane. And these include moving wing and tail surfaces. You often see the ones on the wing if you happen to have a window seat over the wing.
Yep.
But those are critical for controlling the motion of the aircraft while in flight. They include things like the rudder, the elevator, ailerons, leading and trailing edges of wings, etc. Now, hydraulics is also responsible for raising and lowering the landing gear.
Mm-hmm.
And I will say that most engine thrust reverser systems, as well as most braking and steering systems on wheels, are also driven hydraulically. Also, many ground systems, such as opening and closing cargo doors, along with maintenance functions that are performed when the engine is not running, are handled by hydraulics. Bottom line, Eric, I would say we find hydraulics is incredibly important to the safe and reliable operation of the aircraft, especially in flight,
right,
but also on the ground.
It sounds to me, just in those few examples that you just described, Tim, it's like what I hear, what they all have in common is that you're moving a heavy piece of the aircraft in a controlled fashion, right? I don't want to oversimplify it. Yeah, I don't want to oversimplify it, but and that's really where hydraulics, I think, shines, right? It's the ability and in a small package to move something heavy in a controlled fashion, right?
Yes. We tend to divide them into three categories in the industry. Certainly at Parker, we're divided that way.
Yep.
And first is what I'll refer to as a hydraulic system, and that's what we're responsible for here in Kalamazoo. The second category is what I'll call fluid conveyance. It includes equipment such as the hoses, the tubes, fittings, regulators, fuses, etc., that move the fluid around the aircraft. And this is handled at the Strataflex division of Parker Aerospace. And then the third category, we've mentioned it briefly, is flight control actuation. That's the equipment that actually makes the physical connection between the hydraulic fluid and the surface to be moved.
Mm-hmm.
It could be in the form of a piston cylinder actuator that moves landing gear. It could be a ball screw driven by a hydraulic motor, or a rotary torque shaft moving a wing surface. And that flight control actuators are designed and manufactured at the Control Systems division of Parker.
Right.
But coming back to specifically the hydraulic system division here, Eric, I would say that system includes anything, first of all, related to the generation of hydraulic power. So the most obvious of that is a pump, engine-driven pump most commonly, but also electric motor pumps and also accumulators. Then I would say it also includes anything related to the storage and the conditioning of that fluid.
Mm-hmm.
It would include equipment such as reservoirs, filters, air bleed valves, and so on. And finally, I would say it includes anything related to the control and monitoring of that system. And some examples of that would be control valves, switches, transducers, cockpit indication, software, many others.
Yeah.
But all those things we do here in Kalamazoo. I would say one of the key differentiators for the hydraulic systems division here in Kalamazoo is not only are we capable of designing and supplying all this equipment, but we are definitely the leader in being able to architect or design that hydraulic system on behalf of the airframer.
Yeah.
And so this includes not just the engineering, but it includes, key deliverables such as reliability analysis or safety analysis required for the airframer to certify the system. But, part of your question is also, how does hydraulics earn its way onto the airplane? And so, and you touched on it, right?
Yeah.
It's the number one advantage of hydraulics, I think, over any other motion control technology, is its high power density. Right. That is to say, it has very high power to weight ratio.
Right.
A lot of power in a small package, as you mentioned. So, and a good example would be is if we would compare an electric motor and a hydraulic pump, both of which have equivalent power ratings, that electric motor would probably be heavier than the hydraulic pump by a factor of 2 or 3.
Yeah.
So for an aircraft where every pound of mass must be paid for and the cost of fuel to lift it, hydraulics really earn their way on the aircraft.
And as we listen to that very, very detailed list of products and integrated services, if I can call it that, that are necessary to put all of that hydraulics on, you get a sense of the engineering work that must go into this to make it function and make it interface appropriately with all the other systems on the aircraft. So I wonder, I know Parker's doing a lot of innovative things in this space. Maybe you can pick one or two examples and we can go into them in a little bit more depth to kind of describe for us what it is and what's unique about it and how it works on the aircraft.
But let's take a hydraulic pump as an example.
Okay.
Hydraulic pumps are the heart of the hydraulic system, and they're definitely one of the core product offerings from Parker Hydraulic Systems Division. EDP is an acronym that I will commonly use here for engine-driven pump. And these EDPs are the primary source of hydraulic power generation on virtually all aircraft today. Our typical engine-driven pump configuration, it's a pressure-compensated variable displacement axial piston pump.
Mm-hmm.
And this pump varies the volume of the fluid that it delivers to the system to maintain the system pressure. At Parker, we often refer to the components in the pump that actually accomplish the pumping task as the rotating group.
Right.
And this rotating group consists of a cylinder barrel containing 9 pistons, and it's driven by the engine gearbox via a splined shaft. And as the barrel rotates, the pistons reciprocate within their bores, taking in and discharging fluid through a stationary valve plate that interfaces with the inlet and discharge ports of the hydraulic system on the airplane. During this operation, the pump outlet pressure, it's controlled by a compensator valve inside the pump. And this compensator valve maintains the desired system pressure by regulating the displacement or the output flow of the pump,
right,
in response to those system pressure changes. So, for example, if the pilot activates the landing gear, lowers the landing gear, that's a huge flow demand required to move that large actuator,
right,
and it results in a large surge in flow from the pump. That in turn results in a drop in the system pressure. The compensator in the pump senses this pressure drop and commands an increase in pump flow until the pressure level is restored.
right.
So that's kind of just a brief description of how I would try to describe the operation of our engine-driven pump.
You did an excellent job there, Tim. And just, I guess one question that jumps immediately to my mind is there one pump on the aircraft for all operations, or are there multiple pumps on the aircraft?
No, there's multiple. Really good question,
Yeah.
Eric. I should have touched on that. So on that 737 with 2 engines, there are 2 pumps, one on each engine, each providing the hydraulic power to a different system on the airplane. And there's some redundancy between those systems.
Right.
In addition, Eric, there are a few small AC motor-driven pumps that are really on the aircraft for backup power if one of those engine-driven pumps should fail. But if you would consider a larger airplane, let's say the Airbus A350, which is typically a long-haul twin-aisle airplane,
Mm-hmm.
it still has 2 engines, but on each engine, in this case, there are 2 pumps. And of those 4 pumps, 2 of them serve one system and 2 serve another. So again, providing redundancy.
Yeah.
So there are multiple pumps on all of these aircraft.
So Tim, can I assume that I'm going to use your terminology here, the EDPs, the engine-driven pumps that you described, they have to be in close proximity to the engines, I'm assuming.
Yes.
And then, so then you were talking about fluid conduits or fluid conveyance, as you mentioned before, to deliver the hydraulic power to the different parts of the airplane. Whereas the electric-driven pumps that you also just mentioned, can those be more distributed throughout the aircraft and closer to the point of application?
Yep, you're getting just a tad ahead of me, Eric, but that was where I was going to segue.
Okay.
Let me mention one last thing about our engine-driven pumps.
Sure.
We have at Parker, we have a unique bearing arrangement that allows the shaft diameter going through the pump to be small, much smaller in diameter, thus allowing us to have a smaller center line of our pump and resulting in lighter weight and higher performance for a given pressure and flow requirement. But as you indicated, the engine-driven pump, not only is it in close proximity to the engine, it's literally on the engine.
Okay.
It's attached to a gearbox that's running off of the main drive of the engine. So it is inside of that engine nacelle that you typically see hanging below a wing,
right,
containing the engine. A challenge for the engine-driven pump is it's running continuously, right? Because they're not going to turn the engine off. So it's a direct drive off of that gearbox. And also, that environment is very challenging. High heat, high vibration.
mm-hmm.
So we do find that the EDP, while very critical to safe operation of the aircraft, also has to live and run continuously in this challenging environment. That kind of brings me to where you were going, talking about another technology, that of electric motors.
Yeah.
So electric motor pumps have been on aircraft for many decades, but as I mentioned earlier, they're relatively small and primarily for backup or just for ground duty support, such as opening cargo doors. Recent advances of electrical power generation on aircraft, improvements in control electronics, and really, just as we've seen automotive go more electric, we're seeing aircraft go more electric, right? And here at Parker, we recognized that trend quite a few years ago, and we chose to bring the design and assembly and test of electric motors in-house, rather than buying them from our supply base as we used to do. Mm-hmm. So today, we now design, build, and test all of our electric motors in-house. And that capability includes brushless DC motor designs from 28 volt to 540 volt DC, along with both fixed and variable frequency AC motors. And as we were discussing, right, while they're relatively, we'll say low power density, or their high weight is a disadvantage for electric motor driven pumps, they do bring some real advantages, which they can easily be turned on and off with a switch or a software command. So they don't need to be running continuously at times when hydraulic power may not be needed, or may not be needed in large amounts. And it also allows them to get to be distributed anywhere in the aircraft. They're typically in the fuselage, but it gets the pump out of that difficult environment that the EDPs are in.
Right.
So I will say we see a trend, I think, where we'll see more electric motor pumps and larger electric motor pumps coming onto aircraft and used in conjunction with fewer and probably smaller EDPs.
Yeah. Different companies call them different things, but like the entire assembly of the motor, the electric motor, the pump, and even the actuator are sometimes combined together into kind of a single component, for lack of a better way of saying it, right? So is that the kind of technology that we're seeing on these aircraft?
We're seeing some of that. We call that electro-hydraulic actuation. Mm-hmm. And to your point, every flight control surface would have its own electric motor, hydraulic pump, little reservoir, and actuator all in a package.
Right.
I would say those are primarily used today in backup systems. They're alongside the distributed hydraulics that are still common. And there's a difference between the airframers. Some of them are using them and trying to move more in that direction. Others have chosen not to use them at all. So we do make some of those, and but it's not clear to me how much that will go forward in the future yet.
Well, it's interesting. Yeah, I know there's often buzz in the press about all electric aircraft. And I'm a long soldier in this war, if you will. And when you read into the details, you discover that when they say all electric, they don't necessarily mean all electric, because we're still talking about electrically driven hydraulics on a lot of those things. And I guess that really speaks to kind of the future of this technology. You've mentioned a few of these trends. You know, what from your perspective, what do you see as some of the future trends in hydraulics for the aerospace market?
I think I would say I see the biggest challenge confronting the future of the industry is that of sustainability. And so the question to Parker to the hydraulic systems division here. How do we help the airframer, the company, right, that is designing and manufacturing the airplane, as well as how do we help the airlines, the companies that are buying and operating the aircraft, to minimize their impact on the environment. We see multiple trends towards sustainability today. Examples would be electrification or more electric aircraft, as you mentioned.
Right.
But we also see trade studies and trends in sustainable aviation fuels. We see people working on a liquid hydrogen powered aircraft, et cetera. So things like that. And how are we preparing for that? I guess the example I'll use, I'm going to talk really what our IR&D team is working on here at Parker Hydraulic Systems Division. Right, they're working on the next generation of products, and examples would include a lighter weight and more efficient pump. And that pump could be used as an engine-driven pump, or it could be used as part of an electric motor-driven pump. Also included is the development of a clutch that would allow on-off selection of an engine-driven pump in flight. Then the engine-driven pump gets to act a lot more like an electric motor pump, right? Being able to be turned on and turned off, saving a lot of fuel and power consumption, but also saving wear and tear on that pump.
That's an interesting idea. I hadn't thought about that one before. So a clutch, you said, to engage the pump to the engine when needed.
That's right.
Yeah.
And again, it's a challenge to design a clutch that works in that environment,
Right.
But it would bring a real advantage to that particular application. Another product that our group is working on is an electric motor-driven power pack. And when I use the term power pack, we use that to describe what I'll say is a mini self-contained hydraulic system. It would have all these different components that today are distributed throughout the aircraft. The reservoir, the pumps, the filters, the different connections, the different valves, the different transducers, etc. And that would all be on one package. If it's fairly large, it might be on some kind of a structure or a frame, but that can just get plugged into the aircraft, and it allows localized power to be placed where needed and used when needed. And a good example would be you could put a power pack into the rear fuselage of the airplane, and that power pack might just service the rudder and the rear elevator.
Yep.
And you might have another power pack in the front of the fuselage or near the center in the landing gear bay, and that might be responsible only for landing gear, or maybe landing gear and wheels and brakes.
Sure.
But it takes away all the distribution and connections of hydraulics that are required, and the constant running of the engine-driven pumps, and you could turn these on and off when needed and have them localized.
I'll tell you, Tim, it sounds like we're really just kind of scratching the surface in the time that we have on all the different, not just current applications, but these fascinating new applications that you're describing of hydraulics in the aerospace market. Maybe in closing here, if you could describe, like, what should we be watching for? Like, what do you think the next innovation is going to be that's going to come onto the marketplace?
It's definitely in the realm of the more electric or the different kind of fuel, whether that's liquid hydrogen or whatever that might be. And I think, Eric, from my perspective, it's hard for us to predict what the winning technology is going to be. So I think the most significant thing that our team is doing here is not just readying these products, but it's the design methodology they're using. They've developed what I'll call is a life cycle cost algorithm. and that evaluates each trade study for a given product based on the entire life cycle cost. And for a given product, that life cycle cost includes the OEM cost, right? The acquisition cost, a one-time cost of buying the piece of equipment.
Mm-hmm.
It also includes the cost of inefficiency, or we might describe it as the cost of energy loss. And that's continuous throughout the life of the product. It's the cost of weight, the fuel burn to carry that product, also continuous through the product life. And then it would include things like the cost of maintenance and repairs and the cost of flight interruptions.
Wow.
I think the key for that life cycle cost algorithm is it allows the airframer or the airline to make informed decisions in support of their sustainability goals.
Yeah.
Right. So we develop these new innovative products so that we can be flexible in supporting whatever of those technologies win out, as opposed to trying to predict which one wins.
Yeah.
Yeah.
Yep. All right. Well, thank you very much, Tim. And I'm sorry, but that is going to have to wrap things up for this episode of Fluid Power Forum. My thanks again to Tim Althoff, who has been my guest on this episode. If you'd like to connect with him, learn more about that fascinating world that he just described, the best way to do that is by his email, and we're going to put a link to his email address in the show notes for this episode. Remember, if you like our podcast, please remember to follow us on Twitter. You can find us there at the NFPA, and keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, you should make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be March 14th through the 18th, 2023, in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.